Good morning, students. Once again, I welcome you to my video lectures on gate. Next problem is on initial conditions. The switch is in position P for a long time and moved to position Q at t equal to 0. So, switch is in position P for a very long time. That means steady state is assumed. It is suddenly moved to Q position. On changing this switch position from P to Q, what is rate of change of voltage V? dV by dt at t equal to 0 plus. So you are familiar with 0 plus and 0 minus notation. 0 minus notation means just before 0. 0 plus means just after the 0, t equal to 0. We use in sentences, just bus miss aitu. It is the same meaning, just. So 0 plus means just after. 0 minus means just before. Now what you are supposed to do first is, first you have to assume that switch is in position P for a long time. Then what happens? Inductor will carry some current. Capacitor will have some voltage on its plates. You have to find out that. Once capacitor is charged to that voltage, then current through that capacitor becomes 0. And inductor carries some current under steady state condition, and you can find that. Now what I will do is, I will call this capacitor voltage as V0 minus and inductor current as IL0 minus. You can find out these two, because if you without finding these two, you can't find dV by dt 0 plus. Now look into the network. 20 volt, 20k in parallel. In parallel with this branch is connected. Don't bother about capacitor. Forget about capacitor, because capacitor is charged to some voltage and current through the capacitor becomes 0. You can find that. What is this voltage? Now what I will do is 20k. Now this resistance is also 5k. It is missing. This resistance is also 5k. Now in this branch, the total resistance is 5 plus 5 plus 10. That is 20. And inductor is not going to decide the current, because inductor is the property that opposes change in current. Now 20k in parallel with 20k. So what happens? 20k in parallel with 20k means 10k. 10k, 20 volts divided by 10k, that is 2 milliamps. Therefore current here is 2 milliamps. Now it branches out to 1 milliamp here, 1 milliamp here, 1 milliamp here, 1 milliamp here. Now that 1 milliamp here is producing a drop of 10k into 1 milliamps, that is 10 volts. 10 volts. Next, current through this is 1 milliamps. Current through this is 1 milliamps. Therefore here IL0 minus is 1 milliamps. And V0 minus, capacitor voltage, is nothing but this voltage, because inductor is continuously carrying current and it is acting as a short circuit. Therefore there is no drop. There is no drop across inductor, because it is carrying a constant current of 0.1 milliamps. 1 milliamps, having a value 0.1 millihenry. Therefore this drop is 0. Therefore V0 minus is same as this resistor drop, that is 10k multiplied by 1 milliamps, that is 10 volts. That is 10 volts. Now you redraw the circuit for the new position of the switch. Now the switch is moved from position P to Q. When switch is moved from position P to Q, this part of the circuit is removed. Physically removed. It is as good as physically removing this. Then then this is going to be connected. Now this is the network that results for t greater than or equal to 0. Now what you do, you apply KCL. To these three branches. Now one, you assume some current, because capacitor is charged to some voltage and it is going to drive current through this part and this part. Okay, and I am applying now. It is no longer 1 milliamps. 1 milliamps flows at instant 0 plus. So inductor is like inertia. So you know that in mechanics, a body having inertia cannot be set into motion if it is at rest, or if the mass having, if a body having inertia is already in motion, it can't suddenly stop. That is inertia concept. Inductor is nothing but inertia. Therefore, at t equal to 0 plus also, IL 0 plus is same as 1 milliamps. Therefore, here I will write this as IL 0 minus as IL 0 plus as 1 milliamps. Next, for a capacitor, now you apply KCL here. This voltage is V0 plus. For a capacitor, you know that Q equal to CV. Charge on the capacitor plates is equal to capacitance multiplied by its voltage, or dq by dt. Differentiate this. dq by dt is current. So current through the capacitor, IC, is equal to C dV by dt. Therefore, dq by dt is current. So we are finding that t equal to 0 plus. Therefore, at t equal to 0 plus, this becomes dV by dt 0 plus. Next, what is current through this? The current through this is V0 plus divided by 5K, because capacitor also is like inductor. For an inductor, current suddenly cannot change. Similarly, for a capacitor, voltage cannot change. It is going to maintain that voltage at t equal to 0 plus, same 10 volts. Therefore, current here will be 10 volts divided by 5K. Therefore, 10 divided by 5K equal to 2 milliamps. So current here is 2 milliamps. Current here is 1 milliamps. And current through this branch is C dV by dt 0 plus. Therefore, C dV by dt 0 plus incoming current is equal to outgoing currents. Outgoing currents are 2 milliamps plus 1 milliamps. That is C value is 1 millifarad. 1 millifarad dV by dt 0 plus is equal to 2 plus 1, that is 3 milliamps, or 3 into 10 to the power of minus 3. So 10 to the power of minus 3, 10 to the power of minus 3 cancels. Therefore, dV by dt is equal to 3 volts per second. 3 volts per second. So that ends the problem. So here the capacitor rate of change of capacitor voltage is 3 volts per second. So this option is correct. 3, because capacitor voltage is marked here with this plus minus. Therefore, this is incoming current. So concepts are to be very much clear. So current, always for a charged capacitor, current flows from positive plate to negative plate. Therefore, this is incoming current. These two are outgoing currents, because I0 minus was like this. Therefore, you have to correctly write. If you make mistake in writing this equation also, you may get the other answer as minus 3 volts per second. It is not correct. It is not correct. Therefore, C dV by dt, C dV by dt is equal to 2 milliamps plus 1 milliamps. So calculation is carried out. So it is fall in voltage. It is fall in voltage. Voltage falls. I will explain that point. Now voltage falls like this. Voltage falls like this. Voltage falls like this from 10 volts, from 10 volts to 0 volts. Now what is dV by dt? dV by dt is the slope of the tangent. The slope of the tangent is the slope of the tangent. It is going to fall. It is going to fall. And C dV by dt. And one mistake I have made here. Here we have to take this Q equal to CV. Q equal to CV. Q V V C. Q equal to CV. One mistake I have made. So Q CV. So current is like this. If current is going like this in a direction opposite, please take here minus sign, minus sign, minus sign. So minus C dV by dt is equal to 2 milliamps plus 1 milliamps. Therefore it is minus 3 volts per second. So the point here is, for a capacitor, if the current direction is like this, if Q is charge, C is capacitance, V is voltage, then Q equal to CV, or dQ by dt is equal to C dV by dt. But we are taking current in the other direction because the capacitor already charged is discharging through the rest of the circuit. Therefore, it is in a direction like this. Therefore, this should be taken with minus sign. Minus C dV by dt 0 plus equal to 2 plus 1 milliamps. Now the answer is minus 3 volts per second. Now, if you draw the tangent, so this is voltage drop across the capacitor. It is falling from 10 volts to 0 volts. At t equal to infinity, it is going to fall to 0 volts. If you draw the tangent to this curve, it is having a negative slope, that is minus 3 volts per second. I hope students have understood this concept. It cannot be plus, it is, that is why in the multiple choice, so to confuse students, another answer is also given as 3 volts per second, which is not correct. Thank you.